fault simulation process, so there are certain cases where the faults can be easily detected and there are certain faults which are difficult to detect. So, there are hard detected faults. So, outputs of fault free and faulty circuit are different, maybe faulty circuit is 0, fault free circuit is 1, or the otherwise, that is 0, faulty circuit is 0 and fault free circuit is 1. So, that cases the faults are detected, but and there is no unknown. So, in that process, so none of the outputs are x and none of the outputs are z. So, in that situation, so we say that the one hard fault has been detected. There are potentially detected fault, whether the fault is detected is not very clear. So, for example, say stuck at 0 fault at the enable signal of a tri-state gate. So, if the output is z, so we do not know whether it is due to a stuck at 0 fault or due to some problem at the tri-state gate output itself. So, that way it is difficult that we cannot detect this fault. So, whether the tri-state gate enable signal is stuck at 0 or not. So, there are certain faults which are oscillatory in nature, they cause the circuit to oscillate. So, output is never stable, and in this case it is impossible to predict faulty circuit output. So, what is the, because output is continually oscillating, so we cannot say. Certain faults are called hyperactive faults, and hyperactive faults as they are catastrophic. So, they cause a lot of events in the circuit. So, as a result fault simulation becomes very time consuming as well as memory consuming. So, whatever fault simulation techniques we have seen, so if those techniques are applied for a stuck at fault on a clock line. So, for stuck at fault at a clock line, since clock line goes to almost everywhere in the circuit. So, it will create a large number of events. So, when it does that, so all those events are to be simulated. At the same time, we need to store lot of faulty gate information, responses and all that. So, memory requirement will also be high. So, if that thing occurs, so the fault simulators, they normally count it as detected, because so much of event is there. So, it is definitely going to be detected. So, there may be a limitation on the fault simulation on the number of events for a particular fault, and if that limit crosses, then that fault may be taken as detected. So, it saves the fault simulation time. If we compare across these fault simulation techniques, first of all from the speed point of view, so serial fault simulation is the slowest. So, naturally if we it is taking each fault separately and each pattern separately and simulating them. So, it is the slowest one. Parallel fault simulation, it is of the order of n cube, where n is the number of gates. It is for deductive fault simulation is big O n square. Concurrent fault simulation, concurrent fault is faster than deductive fault simulation. So, concurrent fault simulation, because so many circuits, so many gates are created and they are done simultaneously. So, that simulation is faster. Differential fault simulation is even faster than fault simulation, concurrent fault simulation, because it simulates only the differential part of the circuit. From the memory usage point of view, serial fault simulation, parallel fault simulation, there is no problem, because serial fault simulation is taking only one fault and one pattern at a time. Parallel fault simulation also usually taking using the memory word or the word size of the processor. So, as a result there is no extra overhead that is coming. So, memory usage is whether you are storing 1 bit or 1 byte. So, it does not matter, ultimately it is counted in terms of words. So, that way they are same. Deductive fault simulation, so that requires dynamic allocation of memory, and naturally it is hard to predict the size, because which faults will get added. So, that is dynamic. So, that way it is going to have some dynamic allocation. Concurrent fault simulation is more severe than deductive fault simulation, because now you have to remember all the faulty gates that are there. So, whatever the due to some fault, so what are the faulty gates outputs, so that are to be stored. So, that way it is memory requirement is high. Differential fault simulation requires less memory than this concurrent fault simulation, because of the simple reason that it simulates only the differential part of the circuit. Multi-valued fault simulation to handle unknown X or high impedance Z. So, how can we handle this situation? For serial fault simulation, concurrent fault simulation and differential fault simulation, it is easy to do, because there we have got well defined logic by which we define the operations on X and Z. So, accordingly we can handle those situations, but parallel fault simulation is difficult because now in the memory word I need to store x or z. So, that way it becomes a difficult one. Now, delay and functional modeling capability. So, serial fault simulation there is no problem, because you can say that okay, after this much time this particular fault this transition is going to occur. So, you can simulate after that time. Parallel fault simulation, deductive fault simulation, so they cannot handle delay and functional modeling faults, because particularly the delay faults, because now if we are trying to model delay fault, then for every discrete time interval, so we need to keep a copy of the circuit. So, that is difficult. Concurrent fault simulation, we can do this delay fault testing, and differential fault simulation. So, this is also able to do this delay fault simulation. Sequential circuit. So, serial fault simulation, parallel fault simulation, concurrent fault simulation and differential fault simulation, there is no problem. Parallel pattern single fault propagation. So, this particular case it is difficult. Deductive fault simulation is difficult because there may be many unknowns. So, sequential circuit will create more number of unknowns as there are flip flops. So, due to the increase in the number of unknown, deductive fault simulation is difficult for sequential circuits. This PPSFP and concurrent fault simulators are popular for combinatorial circuits, combinatorial and full scan circuits. Full scan means sequential circuit where all flip flops are connected over a scan chain. So, that becomes a full scan circuit. For those cases, this PPSFP and concurrent fault simulation, so they are popular. Differential fault simulation and concurrent fault simulation, they are popular for sequential circuit. We have seen multiple pass fault simulation. So, because in one pass it creates all the events, in the next pass it does the evaluation. So, this prevents memory explosion problem. So, that way it is good. Distributed fault simulation, so it reduces fault simulation time. So, if we can distribute the overall fault simulation job over a number of computers, so there can be distributed over a number of processors. So, as a result the fault simulation time will get reduced. So, to summarize, fault simulation is very important from many angles, like ATPG. So, if you are trying to develop some automated test pattern generation algorithm, so we need to see about the faults that are already covered by the generated test set, and then we try to augment it by generating further test pattern. So, that way ATPG algorithms, so they very well need this fault simulation. For diagnosis purpose, we need to know what are all the faults detected by a particular pattern. So, we need to identify all those faults for diagnosis purpose. So, that there also fault simulation is important. Fault grading, like how difficult is a fault to capture. So, that way we can grade that type of faults that are present in the circuit. Some faults are hard to detect, some faults are random resistant fault. So, that way there can be several gradings. Popular techniques for fault simulation include parallel, serial, deductive, concurrent and differential simulation. So, what we are looking for in fault simulation is the speed should be high, memory usage should be low, functional blocks we should be able to model, and also we want that sequential circuits also to be treated in fault simulation. Though we can say that sequential circuits are mostly converted today into scan circuits, and then this it becomes a combinational testing problem. So, that way this sequential circuit fault simulation may not be that much required. So, coming to the concluding remarks. So, logic and fault simulation, they are two fundamental subjects in testing that we have discussed, and into the nanometer age advanced techniques are required to address new issues like high performance, high capacity, and naturally the type of faults or type of defects that can occur in the new generation technology. So, that is going to differ from the previous technology. As a result, the fault models also need to be updated, so that we can take care of those defects. So, new fault models are also necessary. So, in the next we will continue with the test pattern generation technique.